Hi, my name is Raghav Kro and report for Lab 2 Lines of Charge. Firstly, let's examine the goals and concepts behind this lab. The primary goals of this lab is to understand the concepts of electric charge and interactions with other charged and neutrally charged everyday objects, and concepts involved are Coulomb's law and forces. We're going to be using the above concepts from Lab 1, and we're going to try to create a more accurate simulation of charges across the length of the tape. Now, the experiment was set up based on the prescribed manner. The following values of the variables were used and found out from the experiment. The length of one of the pieces of tape was 10 centimeters. The mass was 10 to the negative 4 kilograms. The distance was 1.2 centimeters. And the magnitude of gravitational force as calculated was 10 to the negative 3 Newton. And the magnitude of electric charge on the floating tape was calculated to be 1.25 into 10 to the negative 8 coulomb. There can be multiple sources of experimental error in the values that we just found out. These may include parallax error, humidity variations, tape brand variety, and the charge might have been grounded due to contact with the skin, and there was a certain degree of estimation used in seeing when the top tape was floating. We can examine a simplified model which we used to calculate the electric charge in Lab 1. And on the right, you can see a simplified model that was used to calculate the electric charge that was shown in the previous slide. In the course of this lab, I will be creating a potentially more accurate model, which is based on the charge calculations from this simplified model, and then calculates the force, does the force calculations using the more complicated model. The more complex simulation model looks like something which is on this slide on the right. To more accurately model the charge distribution across the length of the tape, the starter code for this lab was modeled as a string of point charges equidistant from each other. Looking at the interactions between the point charges on one tape and the point charges on the other, we can more closely and accurately model the interactions in the real system. Here is my simulation code, which you can also find linked in the same assignment. Now, first thing that I did was create the simulation using the charge values that I calculated in Lab 1. And the output shows that my calculated charge from the simplified model results in an electric force value close to the gravitational force that is expected from a tape of this weight. This shows that our measured value of distance of separation is also really close to the real value, and the electric force magnitude value is off by only about 15.3%. Then what I did was I went ahead and edited the charge values to come close to the magnitude of gravitational force. And I edited the charge values by just 0.1 into 10 to the negative 8c. And I edited it to be 1.3 into 10 to the 1.35 into 10 to the negative 8c. And the value of the electric field became 9.8 into 10 to the negative 3 Newton, which matches the magnitude of the gravitational force. And this error in my calculated charge value can be attributed to the uncertainty in the measurement of the distance of separation, as well as the other factors that I talked about earlier. Thank you.